Hello, good morning. I'm audible?
Yes, sir, you're audible.
Okay, thank you. Up till now, as per our subject is concerned, we have already covered all the syllabus. But from this month, or from last week, there will be change in timetable regarding the completion of the practical and in somewhat completion of the in remaining. And there will be provision for the revision of the chapter in order to improve the attendance. Students, those are set as a defaulter, right? In order to improve your attendance, we have made provision of a lecture for the revision of different chapters of respective subject. In that concern, uh, up till now we have completed two tests, IAC test. First test is on chapter first, second test is on chapter third, fourth. And meanwhile, also we have conducted 4 UT respectively on each chapter up to chapter number 4. 4 UT and 2 IAC test. I think majority of the students have completed that test, right? If anybody is remaining, let me know how many students are remaining. Accordingly, we will make certain provision in order to complete that test, right? Now, from today, um, I think various time I have taken a revision on each chapter of the first section, right? Chapter number 1, chapter number 2, and chapter number 3. I have already covered, right? But in second section, we cannot able to take a revision of the chapters frequently. So that in today's lecture, we are going to take a revision on a chapter number 4, right? I will give the brief idea on this chapter, what we have to study under this chapter, and what we have to uh, gain by learning that chapter. What you have to do, I will take a recap within a 10 to 15 minutes on that chapter. Then you have to study that chapter by using the PPTs, by using the notes that I have already given to you. So in today's first lecture, we have covered the first chapter, fourth chapter, and whatever the session is afternoon. At that session, we have to conduct one demonstration experimentation. And in last session, we may plan for the test, those who are remaining on UTs or IS, right? Likewise, we have made the schedule. Now today, as per our discussion, we will start with the chapter number 4. The screen is visible to all. Hello.
Yes, sir.
Okay. Uh, the chapter number 4, it will be mainly focusing. it will be starting of a second section. In second section, you have to study 3 chapters. Unit number 4, unit number 5, and unit number 6. Unit number 4, it will give the brief introduction about the pneumatic system and also focus on a actuators, pneumatic actuators. As far as pneumatic word is concerned, it only focusing on study of a pressurized air or study of a pressurized gas in order to carry out different mechanical operations. If you are considering this content, we have to study what is the pneumatic system, how it works, what are advantages and limitations, and the application of the pneumatic system. Also, you have to compare hydraulic and pneumatic system. Mainly, you have to focus on symbols of the different devices which are used in a pneumatic circuits. And the second part of this chapter, it will be focused on a pneumatic actuators. Actuators are nothing but the cylinders and motors. If you are considering cylinders, these are the linear actuators, and if you are considering the motors, they are the rotary actuators. Where you have to study different types of the actuators. It may be a linear actuator, it may be a rotary actuators, right? Now, what is pneumatic? Pneumatic is nothing but the branch of the fluid power, as like hydraulics, right? In hydraulics, the pressure energy of the liquid or oil is utilized to carry out the mechanical operation. Likewise, in pneumatic, the pressure energy of the air or gases it is utilized in order to carry out different mechanical operations. So, pneumatics is the second branch of the fluid power which utilize the air which is freely available and which will act as a working medium in order to transmit the power from the source input to the destination, that is the output. As we know, air is easily available, non-hazardous in nature. So this pneumatic, it will be found variety of applications, especially in case of industry as well as in case of automation. So this is a brief introduction regarding the pneumatics. Pneumatic म्हणजे काय रे जाणं याच्यामध्ये एअर pneumatic हा शब्द आपण स्पेशली गॅसेस साठी यूज करतो. एअर अँड गॅसेस. एअर कॉम्प्रेसिबल आहे, त्या कॉम्प्रेसड एअरचं प्रेशर वाढलेलं असणार, ती प्रेशराइज्ड एअर आपण यूज करणार जेणेकरून वेगवेगळे मेकॅनिकल ऑपरेशन्स आपण परफॉर्म करणार. हायड्रॉलिकचे कम्पॅरेटिव्हली न्यूमॅटिक बेटर का? कारण एअर इझिली अवेलेबल आहे, फ्रीली अवेलेबल आहे, नॉन हॅझार्डस आहे, राईट. हे बेसिक आहे, बेसिक बेनिफिट झाले न्यूमॅटिक्स, राईट. लाईकवाइज देर आर सर्टन advantages of pneumatic circuit. Air easily available आहे, नीट आहे, क्लीन आहे, फ्युजन खूप कॅरेक्टरिस्टिक असते एअरची. It can be easily transported under the pressure. No reservoir is required, no return line is required because जे काही रिटर्न फ्लुइड आहे हायड्रॉलिक मध्ये तुम्हाला ते टँक मध्ये स्टोअर करावं लागतं, पण न्यूमॅटिक मध्ये ती एअर तुम्ही ऍटमॉस्फिअरला फ्रीली एस्केप करू शकता. इनिशियल आणि ऑपरेटिंग कॉस्ट कसे कमी राहते, ऑपरेशन इझी असतं आणि क्विक असतं. आणि एअर लाईट इन वेट आहे, त्याच्यामध्ये त्याच्या रिलेटेड ज्या सिस्टीम्स असतील त्याही सिंपल असतील आणि लाईट इन वेट असतील. दीज आर द सर्टन advantages of the pneumatics. आता limitations काय? Sure. By using the pneumatic, we can use the pneumatic system up to maximum pressure up to 10 bar, 8 to 10 bar. So there will be limitations for the. If you are considering the accuracy, there will be possibility of a leakage of air. So it may adversely affect the accuracy of the performance as compared to the hydraulic system. Also, pressurized air storage. You have to store that air in a reservoir, and then you have to supply. You cannot directly supply compressed air to a particular application because compressors are having certain limitations to increase the pressure of air. But majority of the pneumatic devices, it will be operating at a pressure more than the pressure uh, prepared by the compressor. So in air reservoir, we are continuously pushing the pressurized air in an air tank. So the pressure of the air in an air tank, it will be increases, and that pressurized air, it will be used or supply to the different devices of the pneumatic circuit. So these are the limitations. Now, the main part, it will focus on what is a pneumatic actuator. Actuators are the devices where you can convert the pressure energy of the air into mechanical energy in order to carry out certain operations, mechanical operations. So, which are these pneumatic actuators? Pneumatic actuators are nothing but the converting the air pressure delivered by the air circuit into applied force and motion, straight line or rotary motion. न्यूमॅटिक ऍक्च्युएटर्स म्हणजे काय, ते असे एलिमेंट्स आहेत की ज्याच्यामध्ये इनिशियली बाय युजिंग द ऍक्च्युएटर्स आपण काय करतो, जी काही प्रेशराइज्ड एअर आलेले तर एअर प्रेशर कोण करणार, कॉम्प्रेसर. राईट, दीज आर द इनपुट एलिमेंट्स ऑफ द न्यूमॅटिक सिस्टीम. न्यूमॅटिक सिस्टीमचा इनपुट एलिमेंट काय असणार, कॉम्प्रेसर. कॉम्प्रेसर काय करणार, मेकॅनिकल एनर्जीचा यूज करून एअरचं प्रेशर यूज करणार, प्रेशर वाढवणं. म्हणजे काय, मेकॅनिकल एनर्जी इज कन्वर्टेड इनटू प्रेशर एनर्जी. ती प्रेशर एनर्जी आपण कुठं स्टोअर करतो, टँक. प्रेशर वाढ, नंतर ती प्रेशराइज्ड एअर आपण ऍक्च्युएटरला पाठवतो बाय युजिंग द कंट्रोल एलिमेंट. त्यात फ्लो कंट्रोल व्हाल असतील, डायरेक्शन कंट्रोल व्हाल असतील, प्रेशर कंट्रोल व्हाल. कंट्रोल एलिमेंट काय करतील, 3 पॅरामीटर कंट्रोल करतील, प्रेशर, डायरेक्शन आणि फ्लो रेट. आणि लास्टला ते कॉम्प्रेस्ड एअर, प्रेशराइज्ड एअर कुठे येते, न्यूमॅटिक ऍक्च्युएटर. त्याच्यावरतीच आपण फोकस करतो चॅप्टर मध्ये. न्यूमॅटिक ऍक्च्युएटर म्हणजे काय, जिथं प्रेशराइज्ड एअर येते आणि त्या एअर प्रेशरच्या साहाय्याने आपण वेगवेगळे मेकॅनिकल मोशन अचीव्ह करतो बाय युजिंग डिफरंट डिव्हायसेस. मग कुठले डिव्हायसेस आहेत, किंवा सिलेंडर असतील किंवा एअर मोटर, त्यांना काय म्हणतो तुम्ही, ऍक्च्युएटर्स. इफ दे आर द सिलेंडर, दे आर लिनियर ऍक्च्युएटर्स. लिनियर ऍक्च्युएटरचं एक्झाम्पल काय असणार आहे, सिलेंडर. रोटरी ऍक्च्युएटरचं एक्झाम्पल काय असणार आहे, मोटर. सिलेंडर म्हणजे काय, जे रेसिप्रोकेटिंग मोशन प्रोड्यूस करते, आणि मोटर म्हणजे काय, जे रोटरी मोशन प्रोड्यूस करते. So all the pneumatic actuators, it involves air cylinder and air motor. We may classify that air cylinder based on functioning, single acting, double acting, tandem, or rotary, based on a type of application, light duty, medium duty, heavy duty. If you are considering the first type of cylinder, that is a single acting air cylinder. याच्यामध्ये काय, इनपुट एअर तर इथून हा पिस्टन मागे जाईल. राईट, दिस विल बी द cylinder tube, end cover. It is provided with this piston rod with spring supported. This will be the piston, it will for pushing. इथून तुम्ही एअर पास करा, पिस्टन पाठीमध्ये जाईल. राईट, so in case of a single acting cylinder, we are providing one port. It will be act as inlet and outlet port in one side of the piston. So it will be called as a single acting. So इथून एअर आत आली की हा पिस्टन पाठीमध्ये जाणार आहे. एअरचं जेवढं प्रेशर जास्त तेवढं त्या अगेन्स्ट स्प्रिंग फोर्स हा पिस्टन पाठीमध्ये सरकला जाणार आहे, आणि इथं प्रेशराइज्ड एअर आत येणार आहे सिलेंडर. हा पिस्टन बाहेर आल्यामुळे यू कॅन गेट द रेसिप्रोकेटिंग ट्रान्सफर मोशन. Right. After application, when you are reaching to a certain distance, there will be change in direction of direction control of position. Because of that, here it will be moving outside. So because of the springing action, ही जी काही स्प्रिंग कॉम्प्रेस झालेली आहे, कॉम्प्रेस झालेली स्प्रिंग इकडले एअरचं प्रेशर कमी व्हायला लागलं की एअर बाहेर यायला लागली, त्या साईडचं प्रेशर कमी होणार. स्प्रिंगिंग ऍक्शन मग पुन्हा हा पिस्टन इनिशियल पोझिशन. This would be a single acting vessel. Now this would be a double acting vessel. Here we will use inlet. Here is the outlet. इकडून एअर पास केली, इथं जी पहिली प्रिव्हियस एअर आहे ती इथून बाहेर पडणार आहे. त्यामुळे हा पिस्टन राईट साईडला मूव्ह. जेव्हा इकडून एअर पास करा, हा पिस्टन लेफ्ट साईडला मूव्ह होणार. त्यावेळेस इकडे असलेली एअर इथून बाहेर पडणार. So in case of a double acting air cylinder, we are having the two port on either side of the piston, right? या पिस्टनच्या एका साईडला एक पोर्ट आहे, या पिस्टनच्या दुसऱ्या साईडला एक पोर्ट आहे. Because of that, piston can be moved forward and backward by supplying pressurized air at each port to each port. इकडून पाठवलं प्रेशराइज्ड एअर, इकडून पाठवलं तर पिस्टन राईटला मूव्ह. प्रेशराइज्ड एअर इकडून पाठवली तर पिस्टन लेफ्ट. Telescopic cylinder, it mainly used in a truck, right? Dumping trucks, right? Telescopic cylinder. इथं लक्षात येतं. It consists of more than one cylinder arrangement, right? इथून ज्यावेळेस एअर आते हा ए एरिया, इथं एअर प्रेशर क्रिएट होईल. It will move this cylinder in upward direction. हा पार्ट इथं मॅच होईल. The air complete fulfill with pressurized. नंतर एअर बी सिलेंडर मध्ये जाईल, नंतर सी मध्ये जाईल, आणि हा थ्री सिलेंडरचा रॅम किंवा पिस्टन रॉड हा वरती. I am audible? Hello? I am audible to all. Hello, Deep Jyoti? Okay, Neha. In case of a telescopic cylinder, when in order to rise this dumper, supply the fluid from the bottom, and in order to lower this cylinder, you have to supply the air from the top side into the seat box. Now, whatever we have studied, it will be related to the linear motion. So it will be related with the cylinder. Whenever you are required to a rotary motion, at that time you go for the rotary actuator, that is the motor. This is a vane type limited rotary actuator. This will be a single vane, and when you are supplying the air from this side, it will be moved in an anti-clockwise direction, and its motion is limited up to this restriction, to this. Then you have to supply the air from this side. This vane will be moved up to this location. So there will be a limiter movement. Here we are getting the separate detailed view of a one vane, which is mounted on a rotor. Then dual piston type limited rotary actuator. Here we may supply the air from this side. At that time, this piston it will be moved towards the right hand side. So this pinion it will be rotating in clockwise direction. पण किती मूव होईल तो, किती रोटेट होईल, पार्शियली रोटेट होईल. जेवढे टीथ त्या रॅक वरती आहेत आणि हे टीथ या पिनियनला रोटेट करते तेवढीच पार्शियल मोशन. नंतर काय कराल तुम्ही, इकडून मोशन, इकडून प्रेशराइज्ड एअर पास करा. इथे एअर येईल, इट विल मूव्ह द रॅक toward the left hand side. आणि इकडे जी काही एअर होती ती इथून इकडे येईल आणि इथून अशी बाहेर. त्यावेळेस काय होणार आहे, हा रॅक इट विल बी मूव टुवर्ड द लेफ्ट हँड साइड. बिकॉज ऑफ दॅट दिस पिनियन इट विल बी रोटेट इन anti-clockwise direction like this. It is the rotary piston. Now Vane type gear motor. As we have already discussed in hydraulics, this is the rotor on which radial slots are provided. It is mounted with the vanes provided with the spring. Because of the spring tension, vanes comes in contact with the inner part of the rotor. Inlet आहे, इथून एअर आत येणार, एअर इतर आहे. It will be get trapped between the pocket of two vanes and casing. Casing आणि या दोन वेनच्या पॉकेट मध्ये ती एअर ट्रॅप केली जाईल. Then it will be moved toward the exhaust. This will show the exhaust. इथून एअर आत येईल, कॉम्प्रेस करत 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 एक्झॉस्ट पर्यंत येईल आणि इथून ती बाहेर पडेल. बिकॉज ऑफ अ कॉम्प्रेस्ड एअर, प्रेशराइज्ड एअर, this rotor it will be rotated and you are getting rotary motion at the shaft of this vane type gear motor. By using the pressurized air, we can rotate the shaft of the gear motor, vane type gear motor. Likewise, gear motor. Instead of vane, we are using the spur gear. There are two gears. Whose gear teeth are meshing with each other. When you are passing high pressurized air over here, that pressurized air it will get trapped and imparting the force to the gear, so that gear it will get rotated. That trapped air it will be escape from other side of the motor. Because of providing a motion to the gear, that pressurized air coming from this side, it will be get low pressure. Because that pressure energy of air, it will be utilized to rotate this gear. हे जे दोन गिअर आहे ते रोटेट करायला आलेली हाय प्रेशर गिअर कारणीभूत ठरतात. यापैकी कुठल्या तरी एका शाफ्ट हा ड्राईव्ह वरती असतो आणि दुसरा फ्रीली रोटेट असतो गिअर. Radial piston technique. Here also we are providing, this will be the cylindrical block, this will be the rotor, these are the piston 1, 2, 3, 4. This will be the fluid outlet for here and this will be the fluid inlet. इथून compressed air आत येणार, किती पास होणार, किती पास होणार. If you are observing this portion, compressed air it will be fed to the piston 3. Because of that piston it will be moving in upward direction. If you are observing this position, the piston 2, it's the passage for the movement of the air, it will be gets blocked because of this wheel. Now this is the fluid outlet. Whatever the compressed air after use, its pressure it will be gets decreases and it will be coming out from this. So as the rotor it will be rotates, accordingly this piston it will be move inward and outward to this cylinder. Likewise, we are getting the rotary motion. So in this way, we are studying different types of the actuators, pneumatic actuators, right? This is the fourth chapter. This is the fourth chapter, in which we have to focus on a introduction to the pneumatic system and actuators, right? So this will be the brief review on the fourth chapter. Okay, I think it will be sufficient for the today's lecture. You may go through the slides, notes, right? and you also study the objective based on the chapter that I have already provided to you. Now I request the students from the division A to write your roll number in chat box. Now students from the B division, write your roll number in chat box. Okay, anybody is remaining from A division and B division? Okay. So I request all of you to go through the chapter number 4, go through the notes, PPTs, and MCQs, and cover that chapter, study that chapter, and if you have any query, please call me personally. Okay? For today's lecture, I think it is sufficient. You go through the notes. Okay, we will stop over here. In middle session, we will discuss on is it sufficient? Hello? Have you got the brief idea? Okay, thank you.